we go. This is a, oh, you know what? We have a little bit of, got some stuff to hand back, I think, here. No, wrong class, wrong class. How about you get here? Okay. There you go. Got one paper to hand back to Aaron. Just to review one thing is that if it's never turned, the only time it's too late to turn in homework is after the test for that chapter. So we're in chapter 4. It's too late for chapter 3 homework. The reason why is that chapter 3 homework was to prepare you for the chapter 3 test. Homework is due the next class period. All right. Sometimes I give a little grace on that, but if you turn in something now that is at, say, the beginning of chapter 4, that's half credit. Okay, get half for that. But it's going to be half all the way up to the chapter 4 test. All right, up to the chapter 4 test, and you'll get half of that. After chapter 4 test, too late. Moving on. We left off on this problem. We were graphing these log problems, right? And as with every graphing problem we've done almost this whole semester, you come up with a plan, right? Plan. You start with a function whose graph you know, and you get those from library of functions. So we're going to start with y equals natural log of x from the library of functions. Okay. From the library of functions. Let me get. I'm very far behind in my notes. That's number 1. Number two, we need to transform this function into the one we don't know the graph of. My suggestion is leave shifts to last. Leave shifts to last. Do stretches and compressions and reflections first. If you're good, really good, you can do them in any order you want. But if you don't do them in the order I just said, almost everyone makes mistakes. So I am going to, let's see here. That 2 is a shift. X minus 1 is a shift. That negative sign, though, is a reflection. So my next step, y equals minus natural log of x. And that is a reflection about x-axis or y-axis? X. 3. Well, let's do the x minus 1 part. Y equals minus log x minus 1. That is a shift up, down, left, or right. Oh, Eli didn't even blink. That's the way it ought to be, bro. Ninja move, man. Hey-ya! Shift right 1. X minus 1 is a substitution. And substitutions are going to be horizontal and are counterintuitive. So it's a minus. It shifts in the positive direction. Counterintuitive. 4. That 2. So I'm going to add 2. And convince yourself adding 2 on the end is the same as adding 2 on the beginning. And that is a shift up. Shift up 2. All right. All right. So we have what? Go to our graph over here on the left, put our preliminaries over here, my final graph over there. First one, y equal log x. We, at some length, talked about the graphs of the log functions last time. Uh-oh. That is graph number 1. That is your basic log graph when the base is bigger than 1. Remember, the base of a log function can be either bigger than 1 or between 0 and 1. If the base, this is log base e, which is bigger than 1. If it were between 0 and 1, the basic shape would be like that. Don't write that on your paper. I'm going to erase it. That's one advantage of electronic over the chalkboard. Next, negative. Now this is interesting. The negative, that's going to reflect it about the x-axis. That's going to be pretty much that. Pretty much what I just erased, right? That's going to be number 2. And now the asymptote is on the positive y-axis. I didn't plan that, but I should act like I did. I didn't plan that. Number 3, shift right 1. Now, my advice is to shift the features of the graph and then draw the graph. So I'm going to shift this. I am going to change the color. This guy right here. Let me change that to something that doesn't get much love. Let me change that to, oh yeah, oh, that's too light. Can't see that. How about brown? There we go. We're going to shift this brown guy over to the right. 1. Now, I'm going to first shift its features, some characteristics. For example, that 1 x-intercept is going to go over to 2. This vertical asymptote on the positive y-axis is going to move over 1. Now I draw that same brown graph. And all I did is it moved it over 1 unit to the right. Now notice you're still tracking, we're still tracking points. So that x-intercept is at the point 2, 0. And that's going to be important because it's about to go up 2. It's about to go up 2. I'm going to take this, all that stuff, I'm going to move it over. Move my plan over. So when I take the red one and go up 2, that's not going to impact my vertical asymptote. It just slides up that asymptote, right? This point here will go up 2. So over here, I have the point 2. It's going to go up 2. So that's the point 2, 2. I have a vertical asymptote, pretty much the same as it is here on the left. It's going to be at 1. And then I draw my graph, right? Oh, it is going to have an x-intercept out here. I'll get to that in a minute. That's the graph. That is meant to be this red graph over here on the left, moved up 2. Now, I'm usually aware of what you can do and not do without a calculator. And be thinking of any questions you have on this. I just want to make a comment first. What about this point here? How would I figure out what that point is? You know enough to do this. Well, how do you get the x-intercept of any function in the universe? You don't plug in 0. You solve the equation equal to 0. You solve the equation equal to 0. So this is our equation. So for x, oh, domain and range here. I'm just going to do x-intercept here. I'm going to solve what? I'm going to solve 2 minus natural log x minus 1 equal to 0. That's going to be the same as natural log x minus 1 equal to 2. How do I get an x from the inside of the log function? I raise e to both sides power. This is something you need to pay attention to. We're going to take e. E is the base of natural log. So e here, e there. So on the right, I got e to the 2. On this side, I got e to the natural log x minus 1. This is the same as equal bases, equal exponents. Equal bases, equal exponents. We've used that principle before, except I'm using it backwards. Here I have the exponents, and since I need to get to that x that's inside the log, I take e to that left side and e to the right side power. E to the log of anything is anything. E to the log of pig is pig. So e to the log of x minus 1 is x minus 1 is e squared. And so x, this is my x-intercept, is e squared plus 1, which is going to be about 8.4. But you don't have to compute the 8.4. This point right here is e squared plus 1. I did that mainly to review how to solve something like that, because that's a skill that you need for other parts here. Other material coming up, and in chapter 5. I cannot emphasize enough about chapter 5. Chapter 5 is chapter 5 is the chapter that the business department is most excited about of this whole class. Ask DeToro or Steve Thompson or Tim Lewis. They're going to tell you the mathematics of finance. Probably one of the most useful that you will have in your whole life, but certainly for business purposes. Okay, any questions on how we got there? This is a pretty stiff graphing problem. The only way, if I could think of a way to make this harder in my evil mind, right? I would have done, don't write this down, I would have done here something like 2 minus x. That would have been a little trickier. We did one like that, we did a couple like that. Don't write that down, I'm going to erase it. So this one had quite a few of the trimmings in it. We've done this process how many times, right? You put your preliminary work on the left, your final one on the right, with details. That someone knows how to get the details of a graph to me That's where the understanding lies. You know, okay. Range and domain. What is the domain? Domain is everything x can be. So you go here on your graph on the right. What can x be? Bigger than, strictly bigger than 1. So the domain is 1 to infinity. What can y be? Look on the graph. What values of y are represented on your graph? All the way to plus infinity, all the way down to minus infinity. Right? And there's our graph right there. Remember that the 1 plot point per pixel, that's why that graph doesn't keep going up. It's all within 1 pixel there. This point of intersection is about 8.4. If you were to find, if you were going to use the zero function on your calculator, you can come up with that. All right. There's some love. Oh, that's got the 1 minus part. Okay. All right. Remember how to handle that. If you don't, come see me. Speaking of which, we are probably going to finish chapter. See, we're on slide 54 out of 80 something. We are probably going to finish chapter 4. Expect a test sometime next week. If not Wednesday, Friday. It won't be before Wednesday.
We are going to have a test on chapter 4.
On chapter 4.
Okay.
Either next Wednesday or Friday. I'll let you know on Friday. We'll see how far we get on Friday. Right? In any case, got Spark on Monday. Got my office hours right here. The usual help resources. You got Khan Academy. You got YouTube. You got the Edge Center. Tutor there, right? This we've done a couple times already. This is equal bases, equal exponents. We just use this. We've been using it in words. What does it mean? If I have the same base, now keep in mind the base has to be positive, not equal to 1. This actually works even if it's equal to 1. Actually, you know what? No, it doesn't. No, it doesn't. If a is positive, not equal to 1, and I have a to some power on the left equals a to some power on the right, those two powers have to be the same. Equal bases means equal exponents. So one of our little ninja tricks here is to get equal bases on each side of an exponential equation. So here's that's our topic, solving exponential equations, right? So let's take a look down here. We've had this discussion. 4 and 32. 4 and 32. Well, 32 is not a power of 4, but they're both powers of 2. 4 and 32 are both powers of 2. We did one similar to this. X minus 1. Yeah, let me go erase it. X minus 1. So 4 is 2 to the 2. 32 is 2 to the 5. In fact, I don't need those parentheses at all over here. We have a property of exponents that x to the a to the b is x to the a times b. So 2 to the 2 times x minus 1, that equals 2 to the 2 times x minus 1. The student will observe. Equal basis, 2, 2. So that's equal basis. Means equal exponents. This means that 2 times x minus 1 equals 5. It's almost as if you can cancel those bold 2's. Very useful property, and this works both directions. Well, 2x minus 2 equals 5. 2x equals 7. X equals 7 over 2. That, I hope, isn't a struggle, that last part, at this point of the game. Equal bases, equal exponents. E, E, E. E, 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 E. We're going to use properties of exponents. What else? E to the x to the x, e to the x squared. I multiply those together. What does this right equal? X to the a divided by x to the b is x to the a minus b. By the way, it would also be equal to 1 over x to the b minus a. But that isn't very useful right now. We need the top one. So this is going to be e to the x minus 2. That's e to the x squared equals e to the x plus 2. Up squared. Okay. Equal bases, equal exponents. I'm getting a little insecure. My board's going to freeze, so I'm going to get out of this real quick and get back in. Okay. Just so my board didn't freeze, I do some work. This means x squared minus x minus 2 is 0. You know 12 ways of solving a quadratic, right? This may factor. X plus 1, x minus 2. Foil that back out, make sure you have it right. I think we're okay. So this means that x plus 1 equals 0, or x minus 2 equals 0, x equal minus 1, or x equal 2. The key step, the one we're learning in this particular unit is right there. Equal basis, you set the exponents equal. Very powerful little rule. If you wanted to, you could check your answers, and I recommend doing it. You can go over here and go, check. We have two answers, x equal, let's do x equal 2 first. We're going to do e to the 2 to the 2 is e to the 4. That's the left-hand side. E to the 2 divided by e to the minus 2 is e to the 2 minus a minus 2 is e to the 4. Check. That answer works. That solution works. X equal minus 1. I'm not going to check every answer, but just to, as a little encouragement for you to do this when you're on a test especially. X equal minus 1. E to the minus 1 to the minus 1 is e to the 1 is e. Then I have, oh, careful here. Kalfa gasapa. Ooh. E to the minus 1 divided by e to the minus 2. Remember our little rule up here at the top, property of exponents. This is e to the minus 1 plus 2. That's e to the 1, and that is e. Check. Smile. Your brain releases happy sauce. There's some love. Next time. I know. You can do without me being such a loving guy. Now the plot thickens a little bit. What do we do with 7? Well, when we had 32 over there, we got the left as a power of 2. The right is the power of 2. Well, the left is a power of 2. 7 is 2 to the what? I'll tell you what it is. It's log base 7 of 2. Ah! That's what it is. That's what it is. But we're going to get there. We'll get there. We'll get there. We'll get there. Log base 7 of 2. Now, there is more than one way to get this correct answer. There's more than one way to get this correct answer. How? Right now, we haven't done logs to other bases, really, that much. We've done some. We've got this particular formula here, that y is log base b of x means b to the y is x. We have that. We have that. We know also that y equals log base b of x and y equals b to the x are inverses. We have that one. Here's the good part. We don't need to do any strange log base. We don't need to do any strange log base here. We can use the log bases that we're familiar with. Log base e, which is natural log, ln, or log base 10, which is log, common log. So natural log of the left equals natural log of the right. I'm solving for x. A property of logs is this 3x can go down front.
Why do you use natural logarithm, not logarithm?
That's a good question. Okay. He's saying, why are we using natural log and not log base 2 or log base 7? One You could. I wouldn't take anything off if you did. Let me finish it this way, and we'll do it that way, and you'll see. That's a really good question, Diego. Very good question. He's saying, why are you have this is base 2 on one side, base 7 on the other. Why are you using log base E? Right? ¿Por qué, Señor Miller? Boy, what do I sound like? I sound like a 60-something-year-old guy who can't speak Spanish. Okay. So 3x is log base 7, log of 7 divided by log of 2. So x is going to be that divided by 3. Divide by 3. And you see when we solve this on the calculator, this expression is right here. Okay. And that equals 0.9357. Okay. Another way to solve that is to use your calculator graphically. We've done this before. You graph y equals 2 to the x, right? 2 to the 3x, excuse me. And then you graph y equals 7, and you figure out the point at which they're the same. And that's the same number. Okay. Now, Diego was, or any questions on that before I go over what Diego was saying? Now, Diego, do you like using log base 2 or log base 7? 2. Perfect. So he's suggesting, he said you have 2 to the 3x equals 7. He says, why not use log base 2 of the left equal log base 2 of the right? So you put 2 to the 3x here, 7 there. Now, the advantage of what he's saying is you have log base 2 and then 2 to a power. Those two undo each other. These two do not undo each other. Because this is log base E, and that's base 2. They don't have the same basis. So those two don't undo each other. These two are inverses. So Diego is saying that is just 3x on the left. And that is log base 2 of 7 on the right. And so x equals log base 2 of 7 divided by 3. And that looks different than that. Yeah. So what do we do? How do we figure out whether this is correct? Yeah, but we don't have a log base 2 button on our calculator.
In Spain, I used to have.
A log base 2 button?
No, I have like a log, and I can put the base.
Oh, I see. You have a log. You know, there might be. You know what?
Because we use
Let me
a
see.
lot of to change the
Let me see
base.
something. I wondered for a second. Oh, there's a little bit of statistics, right? That from today. I know what you're thinking. Mr. Miller, I'll be sure to take the business stats class, not yours. Okay. Maybe on math here somewhere. Maybe there is somewhere here somewhere. Log base. There you go. That'd be interesting. Log, the value, I want 7. Base. I'm going to show you another way here in a second. 2. Enter. Divided by 3. What do I, oh, don't tell me. The calculator froze. I'm having all the luck. Right? We're supposed to redo this oh, I closed the wrong thing. All right. Let's go over here, open that up again. Go over here, open the calculator again. All right, let's do this again. Math. Oh, that's interesting.
Yes, that's why.
2, there you go. All right.
How do you do that?
I knew it was there somewhere. Now watch, you take that, divide by 3. They just added that. I don't think the TI-83 has that. The TI-84 has that. But anyway, does that look familiar? If we didn't lose it on the slide. Oh, we did lose it. Oh, what a moment. Lost all our work. Yeah, we lost it. I'm going to real quickly put that back up. You should have it in your notes already, though. And remember I said that is the same as this is the same as this. And that gives you the solution. Okay? Doing it the way Diego suggested, you're going to do log base 2 of 3x equals log base 2 of 7. This just equals 3. Oh, sorry.
Was 2 and everything.
Yeah. And that this
Mr. Miller,
yes.
so during the test, if I write x equals 2 base logarithm 7 over 3, is that enough, or do I have to like do the entire?
No, you're saying is it all right if you write this?
Yeah.
Yeah, that's fine. That's fine. Yep. I am just adding this to the slides. Yeah, if you write something that's equivalent, I'm pretty okay on that. There you go. This is Diego's contribution to our slides for today. He's made so many, that's true. It's true. So this one is right here. And I don't care which one you pick. And by the way, Aaron, he might be in a cranky mood. He might say, I want to do log base 10. I want to do LOG. Long as he does it right, You get a numerically equivalent answer, fine with me. Let me sort the answers out. I'll be sure the right answers get what they deserve, okay? Yeah, thank you for that, guys. Moving on. Ooh. Well, we do have natural log here. We have log base e. So natural log is the natural one to use, right? So you're going to do natural log of the left equals natural log of the right. Natural log and e to the power, those are inverses. This one here is probably simpler. I should put this one before the last one. And so here, 3x is natural log 20. Okay, I'm going to do something here. I'm going to put the 2 first. Just so there's no confusion that the 20 isn't added to 2. So x is 2 plus natural log of 20 over 3. And that comes out to around 1.67, right? Because this right here, if you solve it the way we've been doing on the graphing calculator, this is y equals 3 to the, e to the 3x minus 2. Is that exponential curve? This is 20. You figure out where they cross. They cross at 1.665. Similarly, if I, up here, if I just compute what that is, right here, that is 1.665. Right? There's some more homework, very similar to what we just did. Skip some stuff except for what we're going to do here in class. Yeah. Oh, that next time on Friday.
Okay.
Yeah. All right. These here are easy to overthink, but people get them wrong all the time. Calculus students get these wrong sometimes. Okay. We're going to use the basic definition of a logarithm. It's the easiest thing I know how to do. So I want to evaluate this. I'm going to call that. Wednesday. All right. So if log base a of 1 is Wednesday, that means a to the Wednesday equals 1.
So if we put evaluate, we have to put an x for Wednesday and then resolve for that.
Yeah, well, yes. You're going to have to put something over here. X, Y. I did Wednesday because I'm being silly. Okay. I did Songfest in another class. I put Songfest on there. One day we're going to do baseball. Now, question. A is a number positive not equal to 1. So what power do I have to raise a to get 1? 0. This means Wednesday. The only power you can raise a positive number to besides 1 and get 1 is 0. Easy to overthink. Easy to overthink. Here's another one. log base A of A equals S for SAC. That means, I should have written here means. This means A to the S is A. A is A to the 1. Equal basis, equal exponents. S is 1. Don't overthink it. But better to think a little extra than get it wrong. Last one. Call this one Y. A to the Y equals 0. What power do I have to raise a number to get 0?
Negative, whatever.
No solution.
No solution. Why do you say that, Thomas?
Because the base has to be 1 at least, positive.
Yeah, see, A's got to be positive something. I can't raise a positive number to any number and get 0. So this is the Y, we would say, is undefined. All right. All done. We're out of time. Probably are going to finish on Monday, so we're thinking maybe next Friday, maybe for the test. That's what it's kind of looking at. I don't think I'm going to finish the chapter tomorrow. So we'll probably finish on Monday. I will tell you for sure on Friday, though. We'll know more when we finish Friday. Okay.
See you, Mr. Miller.
Hey, thank you. Good to see you.